Hello everyone, welcome back. In today's session, we will be diving into Azure Core Services, which is part 4 of the Azure Fundamentals AZ-900 course. By the end of this session, you will have a solid grasp of the four core pillars of Azure infrastructure: compute, networking, storage, and databases. I will walk you through each one. We will look at services like virtual machines, app services, and functions for compute, virtual machines and load balancers for networking, storage options like blob and disk, and database like SQL and Cosmos DB. Along the way, I will also share how to choose the right service for your needs with practical frameworks and real world patterns. Okay, let's get started. Azure Compute. Azure Compute, this is really the engine that powers every cloud application. Compute means everything from running your application logic, processing data, to hosting websites and virtual machines. Think of it like the brain of your cloud app, just like a physical computer needs a processor to run programs. Every cloud app needs compute power. Now, Azure gives you a range of options from full virtual machines where you have complete control all the way to serverless functions that run just on demand. For example, you are building a simple web app. You might use Azure App Services for easy scaling. But if you have a custom business app with complex logic, you might go for a virtual machine. By picking the right compute model, you directly influence how much you pay, how easily it scales, and how much effort you spend on management. Azure Virtual Machines. Let's look at Azure Virtual Machines. Think of this as infrastructure as a service. So you have full control over the operating system, your patching, updates, and applications. Meanwhile, Microsoft takes care of the physical hardware, storage, and data center security. For example, imagine a company that needs to move its legacy payroll application, originally running on Windows Server 2019, to the cloud. Instead of investing in new on premises hardware, they sign up on Azure Virtual Machine. That way, they get the exact same control and flexibility as on prem, but with no big upfront costs for new servers. Here, like, they no need to buy a physical hardware, they just rent the compute. Azure App Service. Azure App Service is a platform as a service, or PaaS. The biggest advantage is that you don't have to manage the underlying servers, like patching the updates, or taking care of the operating system and applications. Azure App Service is a platform as a service, or PaaS. The biggest advantage is that you don't have to manage the underlying servers. Microsoft takes care of the operating system, server maintenance, security updates, patching, load balancing, and scaling, allowing developers to focus entirely on writing and deploying their applications. Here, like Microsoft takes care of all the underlying patching, load balancing, scaling, and these all will be taken care by Microsoft. So you only focus on writing and deployment applications. Azure App Service can host web applications built using technologies like .NET, Node.js, Python, Java, PHP, and many others. It can also host REST APIs, allowing applications such as websites, mobile apps, and third-party systems to securely communicate with each other. In addition, Azure App Service can serve as a mobile backend, providing cloud services that support Android and iOS applications without requiring you to build and manage your own infrastructure. Here, the biggest benefit is you simply deploy your application code and Azure automatically handles the infrastructure behind the scenes. This significantly reduces operational effort while improving availability, scalability, and security. Imagine you are building an online shopping website similar to Amazon or Walmart. During normal business hours, around 2000 customers may be browsing your website. But during Black Friday or holiday sales, suddenly 1 lakh customers visit your website at the same time. If your application is hosted on a traditional server, you would need to purchase powerful hardware in advance, right? And hope it's enough to handle the traffic. So, like in on-premise scenario, like in traditional scenario, you have to buy the hardware. If customers are increasing, if the traffic is increasing, you have to buy the new hardware. But here in a cloud scenario, no need to buy the new hardware. You just simply scale up your app service. If your application is hosted on traditional server, you would need to purchase powerful hardware in advance. With Azure App Service, you simply upload your application code. Azure automatically adds more server instances when traffic increases, balances user requests across multiple servers, installs security patches automatically. It renews SSL certificates. It reduces server instances when traffic drops. Like once the sale ends, the traffic will reduce, right? That time it will reduce the server instances. As a result, customer experience fast and reliable website while your team spends almost no time managing infrastructure. That's the power of platform as a service. You focus on your application and Azure manages the platform. Here, a simple way to remember: with Azure Virtual Machines, you manage the server. With Azure App Service, Microsoft manages the server and you only manage your application. Azure Virtual Machine comes under Infrastructure as a Service. App Service comes under Platform as a Service. These are the best examples for IaaS and PaaS. Azure Functions. Azure Functions is a serverless computing service, which means you don't need to create, configure, or manage any servers. Instead of running an entire application continuously, you simply write small focused pieces of code called functions. Azure automatically runs these functions only when a specific event occurs. These events could be an HTTP request from a web application, or a file uploaded to Azure storage, or a scheduled timer, or a message arriving in a queue, or many other Azure events. One of the biggest advantages of these Azure functions is pay as you go pricing model. Your code is only when it runs only when it is needed, and you pay only for the actual execution time. When there are no requests, there are no running servers, and in the consumption plan, virtually no compute cost. This makes Azure Functions an excellent choice for event-driven workloads, background processing, automation, and lightweight APIs. For example, imagine you are using a social media application like Instagram or Facebook. A user uploads a new profile picture. Instead of keeping an entire virtual machine running 24 by 7 just to process image uploads, Azure Functions automatically detects the new image upload. The function immediately resizes the original image, creates a thumbnail, optimizes it for faster loading, stores both versions in Azure Blob Storage, and then stops running. The entire process takes only a few seconds, right? After that, Azure automatically stops the compute resources. If nobody uploads an image for the next 2 hours, you are not paying for idle servers because nothing is running. This is why Azure Functions is called serverless. You don't manage servers and you pay only when your code executes. Okay, here one more example, like imagine banking application. Whenever a customer transfers money, Azure function is automatically triggered. The function can validate the transaction, send an SMS or email confirmation, update the customer's account balance, record the transaction in a database, and generate an audit log. All of this happens automatically within seconds without requiring dedicated servers to be running all day. Azure functions as an automatic light sensor. When someone enters the room, the light turns on, right? In the same way, whenever the it requires, this function is automatically triggers and it will runs. So here you have to remember virtual machines, you manage the server, that is infrastructure as a service, app service, platform as a service, you manage only the application. Azure functions, serverless, you manage only the code. Azure manages everything else. Azure Kubernetes Service. Azure Kubernetes Service is Azure's managed Kubernetes service that simplifies container orchestration. It is the ideal solution for running large-scale containerized applications. especially those built using a microservices architecture. Before we understand Azure Kubernetes services, let's quickly answer one question. What is a container? So first we have to understand container, right? So what is container? Container packages your application together with everything it needs to run: its code, libraries, runtime, and dependencies. This allows the application to run consistently across development, testing, and production environments. Now imagine your application doesn't have just one container. It has hundreds or even thousands of containers. Managing all of them manually would be extremely difficult. This is where Azure Kubernetes comes in. AKS automatically deploys and manages containers, scales applications up or down based on user demand, continuously monitors container health, restarts failed containers automatically, distributes workloads across multiple servers to ensure high availability. Since Azure manages the Kubernetes control plane, you spend less time managing infrastructure and more time building applications. Imagine you are building a streaming platform similar to Netflix. Instead of building one large application, the platform is divided into multiple independent microservices. For example, one service handles user authentication, another processes subscription payments, another manages movie catalogs and customer orders, another provides personalized recommendations based on viewing history. Each of these services runs inside its own container. Now imagine millions of users logging in during the release of a popular new series. The recommendation service suddenly receives much heavier traffic than the payment service. AKS automatically detects the increased load and creates additional containers only for the recommendation service. At the same time, if a container crashes, AKS automatically restarts it. If traffic decreases later, AKS removes the extra containers to save resources. Users continue streaming without noticing any interruptions. All of this happens automatically without administrators manually starting or stopping servers. Here one more example, like from the e-commerce industry. Imagine a large online shopping platform. It consists of separate microservices for user login, product catalog, shopping cart, inventory, payments, order tracking, notifications. During a major shopping event like Black Friday, millions of customers start browsing products, right? The product catalog service experiences very high traffic, while the order tracking service receives relatively fewer requests. AKS automatically scales only the product catalog containers without affecting the other services. This improves performance, reduces costs, and ensures a smooth customer experience. Containers package applications. Kubernetes manages many containers. AKS is Microsoft managed Kubernetes service that automates deployment, scaling, health monitoring, and recovery of centralized applications. Azure Container instances. Azure Container Instances is the fastest and simplest way to run a container in Azure. Unlike virtual machines, you don't have to provision or manage servers. Unlike Azure Kubernetes service, you don't need to manage a Kubernetes cluster. You simply provide your container image. Azure starts the container within seconds, runs your application, and automatically stops it when the work is complete. This makes ACI ideal for short lived jobs, batch processing, automation tasks, scheduling workloads, and background processing. Since you are built only while the container is running, it's a very cost effective solution for workloads that don't need to run continuously. Imagine you are working for a legacy company. Every night at 11 p.m., the company receives 500 PDF files from different branch offices. These PDFs need to be read, convert into searchable text, watermarked, compressed, and uploaded back to Azure storage. Instead of keeping a virtual machine running 24 hours a day, Azure automatically starts one Azure container instance at 11 p.m. The container process all 500 PDF files in about 20 minutes. Once the job is finished, the container automatically stops and is removed. Since Azure bill you only for the 20 minutes the container was running, you are not paying for the remaining 23 hours and 40 minutes. When no work is happening, you no need to pay. This makes Azure Container Instances extremely efficient for one-time or scheduled jobs. Here you have to remember, like virtual machine IaaS, server runs all the time even when idle. Azure Container Instance starts when needed, stops automatically after the job finishes, and you pay only for the runtime. Azure Kubernetes Service, best for managing many containers and complex microservices that need to run continuously at scale. Here, a simple way to remember ACI is start process, stop pay only for the minutes used. Azure networking. Now, like we have covered Azure compute services, let's move on to the second core pillar of Azure infrastructure, that is networking. Every application needs more than just compute power. Different services need to communicate securely with each other. Users need to access applications from anywhere in the world, and organizations need secure connectivity between their on-premises data centers and Azure. That's exactly what Azure networking provides. Azure networking is responsible for connecting, securing, and routing traffic between your Azure resources and your users. Even if you have on-premises infrastructure, even for on-premises infrastructure. Let's begin with the foundation of Azure networking, Azure Virtual Network or VNet. VNet as your own private network inside Microsoft's global cloud infrastructure. Just like your office has its own internet network connecting computers, printers, and servers, Like that, Azure provides a virtual version of the network in the cloud. A VNet allows Azure resources such as virtual machines, databases, storage accounts, and applications to communicate securely with one another. It also enables secure communication with your on-premises data center and if needed with users on the internet. Here the important feature of VNet is isolation. By default, every VNet is logically isolated from every other VNet in Azure. This means your network traffic remains private unless you explicitly configure connectivity. Within a VNet, you can create subnets. Subnets divide the network into smaller sections, helping helping you organize different workloads and apply different security policies. For example, you might place web server in one subnet, application server in another, database in another separate subnet. This improves both security and network management. Here, like, let's imagine a company is moving into entirely IT infrastructure to Azure. The company has a web server, an application server, SQL server. Instead of placing all these resources in one large network, they create a single Azure virtual network. Inside that, they create three separate subnets. One is for webnet, one is for application subnet, and one is for database subnet. When customer opens the company's website, the request first reaches the web server. The web server securely communicates with the application server. Then application server retrieves data from database server. All this communication happens privately inside the Azure virtual network without exposing internal traffic to the public internet. This architecture improves security, performance, and manageability. VNet is like a corporate office building. The building itself is the virtual network. Each department, HR, finance, IT, is like a subnet. You can think like that. Employees can communicate securely inside the building. Visitors can only access areas where permissions has been granted. Here you have to remember this sequence. VNet, your private network in Azure. Subnets, smaller sections inside the VNet for organization and security. Isolation, each VNet is private by default. Secure communication between Azure resources, on-premises environment, and optionally the internet. No VNet, no private networking in Azure. Network security groups. Think of an NSGs as a firewall of your Azure network. Its primary job is to control who can communicate with your Azure resource and who cannot. You can associate an NSG with either a subnet or an individual virtual machine network interface. An NSG contains a collection of security rules that either allow or deny network traffic. For example, HTTP port 80 for normal web traffic, HTTPS port 443 for secure web communication, or any custom application ports required by your business application. The same time, you can block unnecessary or risky traffic here. So you can only allow the required ports and unnecessary traffic, you can block it. For example, you have a virtual machine. You want to access it from the public internet. Then you have to enable RDP, that 3389 port number, that you need to enable it. Or and then like SSH on port 22, that can be blocked to prevent unauthorized access to Linux virtual machines. You can also deny traffic from unknown or unauthorized IP addresses. NSG use priority based rules. Each rule has a priority number. Lower numbers have the higher priority. If you mention RDP port number 3389 is the priority 1, means after that if you configure to deny that RDP access with number 5 or 6, still it will not block it, it will allow it, because it will work based on priority number. If we'll change that deny access to 1 and allow access to 4, then it will deny it. You cannot access that virtual machine from the internet. Imagine a company hosts its customer facing website on an Azure virtual machine. Customers should only be able to access the website through a web browser. So the administrators creates an NSG with the following rules. Allow port 80 HTTP for normal web traffic. Allow port 443 for secure encrypted traffic HTTPS. Deny port 3389 RDP for the internet. Deny port 22 for the internet. Now when a customer opens the website, the request is allowed because it uses HTTPS on port 443. But if a hacker tries to connect directly to the virtual machine using remote desktop, NSG blocks it because we provided deny port for 3389. Like a bank has a web server, an application server, database server. A security team configures NSGs so that customers can access only the web server on port 443. The web server can communicate with the application server. Only the application server can communicate with the database server. Nobody from the internet can directly access the database server. This layered security model protects sensitive customer and financial data. NSG is like a security guard at the entrance of the corporate office. The guard checks every visitor before allowing entry, right? Like that, NSG also checks that NSG like a security guard at the entrance of a corporate office. The guard checks every visitor before allowing entry. Employees with valid IDs are allowed inside. Unauthorized visitors are denied entry immediately. Similarly, an NSG checks every network request and decides whether it should be allowed or blocked based on its security rules. Here you can remember simply VNet creates the private network, subnet organizes resources within the VNet. NSG controls traffic entering and leaving those resources. VPN gateway. VPN gateway enables a secure encrypted connection between your on-premises network and your Azure virtual network. Instead of using dedicated private connection, VPN gateway creates an encrypted tunnel over the public internet. This means that even though the data travels across the internet, it is encrypted, making it unreadable to anyone who interrupts it. For employees, it feels as though the Azure resources are part of the company's own internet network. Azure VPN Gateway is an excellent choice for small and medium sized businesses, branch offices, remote workers, and organizations building a hybrid cloud environment where cost is more important than maximum network performance. It provides secure connectivity without requiring expensive dedicated network circuits. Imagine a company has its headquarters in Chicago and has migrated its payroll and HR applications to Azure. Employees working in the office still need secure access to these applications. Instead of exposing the application directly to the internet, the company deploys an Azure VPN gateway. When employees log in from the office, an encrypted VPN tunnel is established between the company's network and Azure. To the employees, it feels exactly like the applications are still running inside their office network, even though they are actually hosted in Microsoft's Azure data center. All communication is encrypted, ensuring sensitive payroll and employee data remains secure while traveling. Everyone else travels on public roads, but your company has a private, protected tunnel where only authorized employees can pass. Even though the tunnel runs beneath public streets, nobody outside can see or access what's happening inside. Similarly, Azure VPN Gateway creates a secure encrypted tunnel over the public internet. VPN Gateway secure encrypted connection over the public internet. Express route private dedicated connection plus highest performance. Azure Express Route. Azure Express Route provides a private dedicated connection between your on-premises data center and Microsoft Azure. The key differences from VPN Gateway and Express Route completely bypass the public internet. Instead, your network connects directly to Microsoft Global Backbone, though an approved connectivity provider. Because the traffic never travels over the public internet, Express Route offers higher security, lower network latency, higher bandwidth, more reliable and predictable performance. This makes Express Route the preferred choice for organizations that run mission critical applications or have strict compliance and performance requirements. Although Express Route is more expensive than VPN Gateway, it delivers enterprise grade connectivity for workloads where downtime or network delays are unacceptable. Okay, let's imagine a large international bank. Every second, thousands of financial transactions are processed between its on-premises data centers and Azure. These transactions involve highly confidential customer information and must comply with strict financial regulations. Using the public internet, even with encryption, may not meet the organization's security and compliance requirements. Instead, the bank uses Azure Express Route. This creates a private dedicated connection directly to Microsoft's network. As a result, financial transactions travel securely. Network latency is extremely low, performance is consistent, sensitive banking data never traverses the public internet. This is why banks commonly choose express route for critical workloads. For example, hospitals store electronic medical records, medical images, and patient information in Azure. Doctors need immediate access to this data during surgeries or emergency situations. The hospital also must comply with regulations such as HIPAA. Using express route ensures fast and reliable access to patient records, consistent low latency, a private connection that supports stringent security and compliance requirements. This helps deliver better patient care while protecting sensitive medical data. VPN gateway, the key differences between VPN gateway and express route. VPN gateway uses the public internet and express route uses a private dedicated connection. VPN gateway traffic is encrypted. Express route traffic never traverses the public internet. VPN gateway is lower cost and express route higher cost. VPN gateway is good for small and medium businesses and express route ideal for large enterprise and mission critical workloads. It's suitable for hybrid connectivity and express route best for low latency compliance and predictable performance. Azure Load Balancer. Azure Load Balancer automatically distributes incoming network traffic across multiple virtual machines. Imagine thousands of users trying to access your application at the same time. If all requests go to a single server, that server can become overloaded, causing slow performance or even downtime. Azure Load Balancer solves this problem by spreading the incoming requests evenly across multiple servers. This provides several important benefits. High availability. It eliminates a single point of failure. If one server becomes unavailable, user requests are automatically redirected to healthy servers. Scalability. As your application grows, you can simply add more virtual machines to the backend pool and the load balancer starts using them automatically. Automatic failover. Azure continuously performs health checks. If a virtual machine becomes unhealthy, the load balancer immediately stops spending traffic to it until it recovers. The result is a faster, more reliable application with minimal downtime. Let's imagine you are running an online shopping website like Amazon during a major holiday sale. Um, at exactly 10 a.m., more than 10,000 customers visits the website at the same time. Instead of spending all requests to one server, Azure Load Balancer distributes the traffic across 3 virtual machines. VM1 serves approximately 3,333 users, and VM2 also like that, and VM3 3,334 users. Because the workload is shared, no single server becomes overloaded. Customers enjoy fast paced loads, smooth checkout, and a better. Now imagine that VM2 suddenly crashes because of a hardware or software issue. Azure Load Balancer detects that VM2 has failed its health check. Immediately, it stops sending any new traffic to the server, that failed server. Instead, all new customer requests are automatically redirected to VM1 and VM3. Most customers won't even notice that one server has failed because the application continues running without interruption. This is called automatic failover, and it's one of the key reasons Azure applications achieve high availability. Remember these three key benefits of Azure Load Balancer. High availability. It eliminates a single point of failure. Scalability easily supports increasing numbers of users by distributing traffic across more virtual machines. Automatic failover detects unhealthy virtual machines and stops routing traffic to them. Azure Load Balancer ensures applications remain fast, highly available, and scalable by distributing traffic across multiple healthy virtual machines. Azure DNS. Azure DNS is responsible for translating human readable domain names into mission readable IP addresses. For example, when a user types a website like www.contoso.com, Azure DNS converts that friendly name into IP address like 20.45.10.5, which computers use to locate the correct server. Instead of manually managing DNS servers, Azure DNS hosts your domain's name DNS records using Microsoft's global highly available infrastructure. One of the key advantages is that Azure DNS integrates seamlessly with other Azure services like App Service, Load Balancer, Traffic Manager, and virtual machines. This makes it easy to manage all your DNS configurations from a single platform, often referred to as a single pane of glass management experience. Imagine you own an e-commerce website called www.shopnow.com. Your application is hosted in Azure on virtual machines behind a load balancer. Now, when a customer opens a browser and types www.shopnow.com, they do not know the IP address of your servers. Here what happens? The user enters the domain name in the browser. Azure DNS receives that request and looks up the DNS record. It translates that www.shopnow.com into the correct IP address of your Azure load balancer. The Azure load balancer then forwards the request to one of the healthy virtual machines. The website loads for the user, the user only sees the domain name, not the complex infrastructure behind it. Now imagine one of your application servers is moved or replaced. Instead of changing anything on the user's side, you simply update the DNS record in Azure DNS. Within minutes, all users automatically starts pointing to the new IP address. This makes application management flexible and reduces downtime during changes or migrations. So here simply you can remember like this. You don't memorize phone numbers, right? You remember the person name. In that similarly, you type a domain name. Azure DNS finds the correct IP address behind the scenes and connects you to the right server. Without DNS, users would have to remember complex IP addresses for every website, but that is difficult, right? Like that. DNS means name to IP translation service. It converts domain names into IP addresses. It is highly available and globally distributed. Integrates with Azure services like load balancer and app service. It helps users access applications using friendly names instead of IPs. Azure DNS ensures users can access applications using readable domain names instead of complex IP addresses with fast and reliable global resolution. Azure Storage. Azure Storage provides durable, scalable, and highly secure storage for all types of data. It is designed to store anything from small configuration files to massive databases used by enterprise applications. Among the different Azure storage services, one of the most widely used in Azure Blob Storage. Azure Blob Storage. Azure Blob Storage is a massively scalable object storage service designed for unstructured data. Unstructured data refers to data that does not follow a fixed schema like a database table. For example, images, videos, documents, log files, backups, PDFs, and reports. This all comes under unstructured data. Blob storage is extremely flexible, meaning you can store almost any type of file at any scale. There are three key characteristics of Azure Blob Storage. High durability. Your data is automatically replicated multiple times to ensure it is not lost. Scalability. It can store from a few files to millions of objects without performance issues. Global accessibility. Data can accessed securely from anywhere using HTTPS endpoints. It also integrates with other Azure services like CDNs, which helps deliver content faster to users across the world. Let's understand how blob storage is used in real world scenarios. Media application. Imagine a social media platform like Instagram. Every time a user uploads a photo or video, that file is stored in Azure Blob Storage. These files can be profile pictures, stories, reels, video uploads. Since millions of users upload content every day, Blob storage handles billions of files at scale. Now consider an online shopping website. Every product has images or videos or PDF files like that, right? All of this content is stored in blob storage and delivered to customers when they browse products. Another important use case is data backup and logging. Organizations store application logs, system logs, database backups, compliance reports. Blob storage is cost effective, making it ideal for long term archival data that is not accessed frequently but must be retained securely. Let's take a practical example. Imagine a photo sharing application. When a user uploads a photo, the image is sent from the mobile app. Azure Blob Storage stores the file securely. A unique URL is generated from the image. When another user opens the profile, the image is retrieved instantly from Blob Storage. Now imagine millions of users doing this simultaneously. Blob storage automatically scales behind the scenes to handle billions of objects without performance issues. Think of Azure Blob Storage like a massive digital warehouse. Each file is a package. The warehouse has unlimited storage space. Every package is labeled and can be retrieved anytime using a unique address. Unlike a traditional filing cabinet, there is no fixed structure. You simply store and retrieve files as needed. Blob storage means object storage for unstructured data. It stores images, videos, documents, backups, logs, highly durable and scalable. It accessible via HTTP or HTTPS. It works well with CDN for global content delivery. You can easily remember blob equal to big box of for files. Azure Files. Azure Files provides fully managed cloud file shares that can be accessed standard using standard file sharing protocols like SMB and NFS. In simple terms, Azure Files lets you create a shared folder in the cloud that behaves like a traditional file server, but without requiring any physical hardware or server maintenance. What makes Azure Files unique? Azure Files is powerful because it works seamlessly with existing applications and operating systems. It works with SMB based Windows applications, so legacy applications can easily move to the cloud. You can mount it as a network drive on Windows or Linux or Mac OS systems. There is no need to maintain file server hardware or manage storage infrastructure. It accessible from anywhere with an internet connection, making collaboration simple and secure. Imagine the HR department of a company. The HR team needs a central location to store and manage important documents such as employee contacts or onboarding documents or company policies or payroll related PDFs. In traditional setup, they would use a physical file server inside the office, But with Azure files, the entire team can access a shared cloud folder. Each employee can open files, edit documents, save updates, collaborate in real time. All of this happens as if they are working on a local network drive. However, Microsoft is managing the storage infrastructure. There are no physical servers to maintain. Data is securely stored in Azure and accessible from anywhere. So, even if employees are working remotely, they can still access the same shared files securely. Okay, let's think about developers often need a shared location for build files, configuration scripts, shared project resources. Instead of setting up a dedicated file server, they mount an Azure files share as a network drive. This allows the entire team to collaborate on the same files without worrying about infrastructure management. Think of Azure files like Google Drive, but at an enterprise level, instead of storing personal documents, it stores company level shared folders. It behaves like a traditional network drive, but everything is hosted and managed in the cloud by Microsoft. So users get the familiar experience of file sharing without managing servers or storage devices. Here you have to remember Azure files equal to managed file share in the cloud. It uses SMB and NFS protocols. It can be mounted like a network drive. It is ideal for shared access scenarios and legacy applications. No need for physical file servers. Azure Disk Storage. Azure Disk Storage is used to store the operating system, applications, and data disks that are attached to virtual machines. In simple terms, it behaves like a physical hard drive for your cloud virtual machine, but it is fully managed by Azure. Even if your virtual machine is stopped or restarted, the data stored on the disk remains intact. This is what we mean by persisting storage. Types of Azure disks: standard HDD and standard SSD. It is a cost effective options for general workloads. Premium SSD, high performance disks for production and critical applications. Ultra disk, extremely high performance for mission critical and database workloads. Each disk type is designed to match different performance requirements. Imagine a company is running a Windows Server based payroll application on the Azure Virtual Machine. This virtual machine has an operating system disk, Windows Server, a data disk storing employee payroll records, an application disk. Consider a SQL server running inside a virtual machine. The database files like tables, indexes, transaction logs are stored in Azure managed disks. Even the VM crashes or VM resized or VM is moved to another host, the data remains safe because it is stored on a persistent Azure disk. Think of Azure data disk storage like the hard drive in your personal laptop. The virtual machine is your laptop. The disk is the internal hard drive. Even if you restart your application, your files are still there. Similarly, Azure Disk Storage ensures your VM data remains intact regardless of VM state changes. Azure Disk Storage, Azure Queue Storage. Azure Queue Storage is designed for asynchronous communication, meaning different parts of an application can work independently without waiting for each other. In simple terms, it acts as a buffer or waiting area for messages between systems. When one component of an application generates work faster than another component can process it. Queue storage temporarily stores those messages safely until the receiving system is ready. This helps create disk-coupled architectures where each component can scale and operate independently. The biggest advantage of Azure Queue Storage is resilience. Even if the backend system is temporarily unavailable, messages are not lost. Instead, they are safely stored in the queue and process communication, meaning different parts of an application can work independently without waiting for each other. In simple terms, it acts as a buffer or waiting area for messages between systems. When one component of an application generates work faster than another component can process it. Queue storage temporarily stores those messages safely until the receiving system is ready. This helps create decoupled architectures where each component can scale and operate independently. The biggest advantage of Azure Queue Storage is resilience. Even if the backend system is temporarily unavailable, messages are not lost. Instead, they are safely stored in the queue and processed later when the system comes back online. This ensures no data loss and improved application reliability. Let's understand with a real world example. Imagine an online shopping website during a big sale event like Black Friday. Thousands of customers are placing orders every second. Now the system works like this. A customer places an order is immediately sent to Azure Queue Storage. The backend order processing system reads messages from the queue. It processes payments, updates inventory, and confirms the order. Now imagine the backend system becomes temporarily slow due to heavy load. Instead of losing orders or crashing, all incoming orders are safely stored in the queue. The system processes them one by one when it recovers. This ensures no lost orders and a smooth user experience even during peak traffic. Azure Queue Storage message buffering system. It enables asynchronous communication. It helps build decoupled architectures. It ensures reliability and no message loss, ideal for workloads where components run at different speeds. Azure Archive Storage. Azure Archive Storage is designed for long-term data retention, especially for data that is rarely accessed but must be kept for compliance or legal reasons. This means the data is still safe and durable in Azure, but it is stored in a way that significantly reduces cost compared to hot or cool storage tiers. However, there is a trade-off if you need to access the data. It is not instant. Retrieval can take hours depending on the rehydration process. So Azure Archive is all about cost optimization for rarely used data. When to use Azure Archive storage? Archive storage is ideal for tax and financial records that must be retained for 7 to 10 years. Compliance and audit logs required for regulatory purposes. Old backups and historical snapshots. Medical imaging archives and long term patient records. These are types of the data that are not actively used day to day but must still be securely stored for future reference. Let's understand with real world example. Like imagine a company is required by law to store tax and financial records for 10 years. Every year they generate large volumes of financial documents, invoices and reports. After filing taxes, these documents are no longer actively used, but they must be retained for legal and audit purposes. Instead of storing this data in expensive standard storage, the company moves it to Azure Archive Storage. Now the data is still safe, preserved in Azure. It is extremely cost effective to store long term data. Storage costs must be reduced by up to 90% compared to hot or cool tires. If auditors requests access after a few years, the data can still be retrieved, although it may take hours to become available. Another example like medical imaging files like MRI scans or X-rays are often required to be stored for many years. Due to regulatory compliance, however, these records are rarely accessed after treatment is completed. By moving older medical images to Azure Archive storage, hospitals can reduce storage cost significantly, still meet legal retention requirements. It retrieves data later when needed for audits or medical history reviews. Think of Azure Archive Storage like a long-term warehouse storage unit. You store items you rarely use. The storage cost is very low, but if you want to access something, it takes time to retrieve it. Unlike a regular storage room, archive storage is optimized for saving money, not speed. Archive storage, lowest cost storage tier used for rarely accessed data. It ideal for compliance, legal and long-term retention. It retrieval takes hours, not seconds. Extremely cost efficient compared to hot and cool tires. Hot, frequently used; cool, occasionally used; archive, almost never used. Azure databases. Azure provides fully managed scalable database services that support both relational and NoSQL workloads. In traditional environments, setting up and maintaining databases requires a lot of effort, including patching, backups, performance tuning, and high availability setup. But in Azure, most of this is fully automated. So you can focus more on your application and data. rather than infrastructure management. Let's start with one of the most widely used services, Azure SQL Database. Azure, it provides a complete database platform in the cloud where Azure automatically handles backups, patching, high availability, disaster recovery, scaling. This means you do not need to manage the underlying database engine or infrastructure. Azure takes care of it for you. You simply focus on writing queries, managing schemas, and working with your application data. Fully managed SQL Server engine, but in high availability with 99.99% SLA. Automated backups and point in time restore, automatic patching and updates, built-in security features like encryption and threat detection, elastic scaling based on workload demand. Let's understand this with a real world example. Imagine an online banking application. Every time a customer logins, checks account balance, transfers money, views transaction history. All this data is stored in Azure SQL database. Now, banking systems require strict consistency and reliability. This is where Azure SQL database shines because it supports ACID transactions, ensuring that every financial operation is accurate, reliable, consistent, and secure. When a customer transfers money, the amount is deducted from one account. It is added to another account. The transaction is either fully completed or fully rolled back if something fails. There is no partial update, ensuring financial integrity. In addition, Azure SQL database automatically provides 99.99% uptime SLA, ensures the database is almost always available. Automated backups. So data can be restored if needed, geo replication. So data is copied to another region for disaster recovery. Elastic scaling. So performance can increase during peak usage like salary day or billing cycles. This makes it ideal for mission critical applications like banking, e-commerce and enterprise ERP systems. Azure SQL database, just use it, don't manage it. Azure Cosmos DB. Azure Cosmos DB is a globally distributed NoSQL database service designed for applications that require very fast response times and massive scalability across the world. Unlike traditional databases that are tied to a single region, Cosmos DB is built for global applications from day one. It delivers single digit millisecond latency, meaning data reads and writes happen extremely fast even at a glance at a global scale. Azure Cosmos DB provides several powerful features. It supports multiple NoSQL APIs, including MongoDB API, Cassandra API, Gremlin API, Table API. You can your data. You can replicate your data to any Azure region with a single click, making your application globally available. It guarantees less than 10 millisecond latency at the 99th percentile for reads and writes. It provides automatic scaling of both throughput and storage. So it can handle sudden traffic spikes without manual intervention. Imagine a global online multiplayer game. Millions of players from different countries are logging in at the same time, updating their scores in real time, competing all global leaderboards. Now, every time a player scores points, the data is instantly written to Azure Cosmos DB. Other players see updated rankings almost immediately. Even if millions of users are interacting simultaneously, Cosmos DB handles the road smoothly without delays or downtime. This means it's perfect for real-time gaming applications where speed is critical. A company has millions of smart devices, sensors in factories, smart meters in homes, connected vehicles on the road. Each device sends telemetry data every few seconds. This results in billions of events per day. Azure Cosmos DB can ingest this massive stream of data in real time while maintaining extremely low latency, allowing business to monitor devices instantly, detect anomalies quickly, make real time decisions. Imagine an e-commerce company like Amazon. Customers from United States, Europe, Asia all access the same product catalog. With Azure Cosmos DB, product data is replicated across multiple regions. Customers get fast access to product details regardless of location. It updates to product prices or inventory are reflected globally almost instantly. This ensures a consistent and fast shopping experience worldwide. Instead of storing data in one place, it stores copies around the world. No matter where the user is, they always get fast access to data. It is like having a local copy of your database in every country. Azure Cosmos DB globally distributed NoSQL database. It supports multiple APIs, MongoDB, Cassandra, Gremlin, Table. Provides a single digit millisecond latency. Automatically scales throughout throughput and storage. It designed for global real-time applications. Azure database for MySQL and PostgreSQL. These are fully managed open source relational database services in Azure, which means you get the power of popular open source databases without worrying about infrastructure management. Azure takes care of patching and updates, backups and recovery, high availability, monitoring, and scaling. So, you don't need to manage servers or database infrastructure. You only focus on your application and data. Azure database for MySQL. MySQL is one of the most widely used open source relational databases, especially for web applications. It is commonly used in the LAMP stack, which includes Linux, Apache, MySQL, and PHP. Many popular platforms like WordPress, Drupal, Joomla rely heavily on MySQL. For example, a WordPress blog that receives around 50,000 monthly visitors. Instead of managing and installing MySQL on a virtual machine, the company uses Azure database for MySQL. Azure automatically handles database patching. It backups happen automatically. High availability is built in. Performance is monitored and optimized. The website owner does not need DBA or infrastructure team to manage the database. They simply focus on writing content while Azure manages the database in the background. Azure database for PostgreSQL. For example, in real-time mapping application similar to Google Maps, this application needs to store location data, perform geospatial queries, calculate distances between points, track movements in real time. PostgreSQL is ideal for this because it supports native geospatial extensions like PostGIS. When hosted on Azure database for PostgreSQL, the database automatically scales based on demand. Failover happens automatically if a region goes down. Backups and security are fully managed by Azure. To summarize, MySQL is like a reliable everyday car engine, simply widely used and efficient for most web applications. PostgreSQL is like a high performance engine built for complex, heavy duty and specialized workloads. MySQL Web Apps, PostgreSQL Advanced Analytics. Choosing the right service. All this now we have understand what are all the services are available and how in which scenarios we are working. Now we'll see like at this point we have learned about different Azure services across compute, networking, storage and database. But in real world scenarios, the most important skill is not just knowing the services. It is knowing which service to choose for the right workload. In other words, Azure is not about memorizing services, but about matching the right tool to the right problem. This table provides a simple mapping between your workload requirements and the correct Azure service. We will go through each category one by one. Compute services. First, look at the compute services used for running applications and code. If you need a full virtual server with complete operating system control, you use Azure Virtual Machine. If you want to host a web application or REST API without managing servers, you use Azure App Service. If you want to run code only when triggered by an event, you use Azure Functions. If you need to manage centralized microservices at scale, you use Azure Kubernetes Service. So compute is all about how your applications runs. Storage services. If you need to store images, videos, backups or unstructured files, you use Azure Blob Storage. If you need a shared network file drive similar to a traditional file server, you use Azure Files. Storage is all about how your data is accessed and organized. Database services. If you need a relational database with structured table and SQL queries, you can use Azure SQL Database. If you need a globally distributed NoSQL database with ultra low latency, you use Azure Cosmos DB. Databases depend on whether your data is structured or globally distributed at scale. Networking services. If you need a private cloud network inside Azure, you use virtual network, VNet. If you need a secure connection from on-premises to Azure over the internet, you use VPN gateway. If you need a dedicated private connection with high performance and compliance, you use ExpressRoute. Real world architecture, e-commerce application. Now let's bring everything together with a real world architecture example. An e-commerce application running on Azure. This is where you see how all Azure core services work together to build a production ready, scalable and highly available system. Instead of using one service in isolation, real cloud solutions combined multiple services to deliver performance securely and reliability at glance. Let's walk through the architecture step by step. At the very top, you have Azure Front Door. Azure Front Door acts as the global entry point for users accessing the application from anywhere in the world. It intelligently routes user traffic to the nearest or best performing Azure region, ensuring low latency and fast response times. This means a user in the US and a user in India will both be directed to the closest available application endpoint. Load balancing layer. Once the traffic reaches the Azure region, Once traffic reaches the Azure region, it is handled by the Azure load balancer. The load balancer distributes incoming requests across multiple application instances. This ensures no single server is overloaded. High availability is maintained. Automatic failover happens if a server goes down. This keeps the application fast and reliable even during peak traffic like sales events. Application layer or app service, which runs on Azure App Service. This is where the core e-commerce application logic runs. It handles product browsing, user authentication, shopping cart management, order processing. Since it is platform as a service, Azure manages servers, patching, scaling, availability. So developers can focus only on application development. Data layer, Azure SQL database. This is where all transactional data is stored, such as customer details, orders, payments, inventory, records. Azure SQL ensures ACID compliance for transactions, high availability, automatic backups, built-in security and scaling. This guarantees data consistency for critical business operations. Azure Blob Storage. For media content, the application uses Azure Blob Storage. This stores product images, videos, marketing banners, user uploaded content. Blob storage ensures massive scalability, global accessibility, low cost storage for large media files. This allows the website to serve rich content efficiently to users worldwide. Next, monitor, Azure Monitor, monitoring observability. To ensure everything runs smoothly, Azure Monitor is used. Azure Monitor provides end-to-end observability across the entire application. It tracks performance metrics, application logs, system health, alerts, and failures. This helps IT teams detect issues early and maintain system reliability. Now let's connect everything together. A user opens the e-commerce website. Azure front door routes the request to the nearest region. The load balancer distributes traffic across application servers. Azure App Service processes the request. Azure SQL database handles order and customer data. Azure Blob Storage delivers images and media. Azure Monitor continuously tracks systems health. All these services work together seamlessly as a unified cloud system. Here, think of this architecture like a modern shopping mall. Front door, main entrance of the mall. Load balancer, security and crowd control at entrances. App service is like storing inside the mall, stores inside the mall. SQL database, cache registers, billing systems. Blob storage rooms for inventory and media. Monitor, CCTV cameras and security control rooms. Everything works together to ensure a smooth customer experience. Likewise, Here in Azure, it everything works together. Azure is not about single services. It is about how services integrate to build complete solutions. Compute decision tree. Now let's simplify one of the most important skills in Azure, choosing the right compute service. Instead of memorizing options, we use a decision tree approach. This helps us quickly identify the correct compute service based on the workload requirements. Let's go step by step. Do you need full operating system control? The first question you should always ask is, do I need full control over the operating system? If the answer is yes, then you choose Azure Virtual Machines, because Virtual Machines gives you full OS access, full configuration control, ability to install any software, complete infrastructure level flexibility. So VM equal to maximum control but also maximum management responsibility. Do you just need to run a web application or API? If you do not need OS level control, the next question is, am I just hosting a web application or REST API? If yes, then you choose Azure App Service, because App Service removes server management, automatically handles scaling and patching, lets you focus only on application code. So app service equal to simple deployment without infrastructure management. Is your workload event driven or short lived? Does my application run only when triggered by an event? File upload, HTTP request, timer schedule, message queue trigger. If yes, then the best choice is Azure Functions, because Azure Functions runs code only when needed, automatically scales. You pay only for execution time. So Functions event driven serverless compute. Are you using containers? If your application is container based, do I need orchestration or just a simple container execution? Option 1, Azure Kubernetes Service. You have multiple microservices, you need auto scaling and orchestration. You want enterprise level container management. So AKS equal to complex large scale container system. Option 2, Azure Container Instance. You want to run a container quickly. You don't need orchestration. You want a simple on-demand container job. So ACI equal to fast simple container execution without management overhead. So the compute decision tree looks like this. Need full OS level virtual machine, need web app or API hosting app service, need event driven execution functions, need container set scale AKS, need simple container execution container instances. This decision framework helps you choose the right compute service in both real world architecture and AZ-900 exam scenarios. AZ-900 exam tips. Now let's focus on the most important part of the AZ-900 exam. Service comparisons. Most exam questions are not about definitions. Instead, they test your ability to choose the correct answer, correct Azure service for a given scenario. In this section, we will look at the most frequently tested comparisons. First comparison, Azure Virtual Mission versus Azure App Service. Azure Virtual Missions are infrastructure as a service. You get full control of the operating system, but you are also responsible for patching, updates and maintenance. Azure App Service is platform as a service. You do not manage servers or operating systems. You simply deploy your code. If a question says no infrastructure management, the correct answer is almost always Azure App Service. So VM equal to full control, more management. App Service equal to no server, no server management, just deploy code. Blob storage versus Azure files. Azure Blob Storage is used for unstructured data such as images, videos, backups and documents. Azure Files provides a shared file system accessible like a network drive using SMB or NFS. If the question mentioned a shared folder for a team, the correct answer is Azure Files. So blob equal to object storage, files equal to shared network drive. Azure SQL versus Cosmos DB. Azure SQL database is a relational database. It supports structured data and ACID transactions, making it ideal for financial and business applications. Azure Cosmos DB is no SQL database. So it is globally distributed and provides millisecond latency at scale. If the question mentions global distribution, no SQL, ultra low latency, the correct answer is Azure Cosmos DB. So SQL equal to structured relational transactional, Cosmos DB equal to no SQL, global scale, ultra low latency. VPN gateway versus express route. VPN gateway creates an encryption tunnel over the public internet. It is cost efficient and suitable for general hybrid connectivity. Express route provides a private dedicated connection that does not use the public internet. If the question says private connection with no internet, the correct answer is express route. So VPN gateway, secure tunnel over internet, express route equal to private dedicated connection. Functions versus Azure Kubernetes services or containers. Azure Functions is serverless and event driven. It runs code only when triggered and is ideal for short-lived tasks. Azure Kubernetes service is used for managing containerized microservices at scale. If the question says run code in response to an event, the correct answer is Azure Functions. So functions equal to event driven, serverless, short-lived execution. AKS equal to long running scalable container orchestration. So here you have, instead of memorizing, always ask what is the scenario asking for. Do I need control, simplicity, scale or connectivity? You have to question yourself so that if you understand the concepts, you can easily get it. let's quickly summarize the key takeaways from everything we have learned in Azure fundamentals. Compute runs your applications. Compute is what runs your applications in Azure. Compute services execute your code, host your applications, and process workloads. You can choose different levels of control depending on your needs. Azure Virtual Machines gives you full operating system control. Azure App Service lets you deploy applications without managing servers. Azure Functions Serverless runs code only when triggered. The more control you want, the more you manage. The more you offer to Azure, the simpler it becomes. Networking connects your resources. Networking is what connects everything together in Azure. It forms the backbone of your cloud infrastructure. Virtual networks for private cloud networking, network security groups for traffic filtering and security, VPN gateway for secure internet-based hybrid connections, express route for private dedicated connectivity, load balancer for distributing traffic across servers. Networking ensures your applications are secure, scalable, and properly connected across environments. Storage holds every type of data. Now let's talk about storage. Different storage services are designed for different data types. Blob storage, unstructured data like images, videos, and backups. Azure Files, shared network file system. Azure Disks, persistent storage for virtual machines. Queue storage, asynchronous messaging between applications. Archive storage, long-term, rarely accessed data. Storage is not one service, it is collection of services designed for different data needs. Databases, manage structured information. Used for storing and managing structured and semi-structured data. Azure provides multiple database options depending on the workload. Azure SQL database, relational data with structured tables and ACID transactions. Azure Cosmos DB, globally distributed, no SQL database with ultra low latency. Azure database for MySQL, PostgreSQL, open source relational database services. The key idea is choose based on structure, scale, and distribution requirements. Managed services reduce operational effort. Azure significantly reduces infrastructure management effort. As you move from IaaS, PaaS, serverless, you spend less time on patching, backups, hardware maintenance, infrastructure management. Instead, you focus more on building applications and delivering business values. Now that we have completed part 4, Azure Core Services, you already understand how Azure builds applications using compute, networking, storage, and databases. We saw how real world systems like e-commerce applications come together using multiple Azure services working in sync. But building cloud applications is only half of the story. The next important step is controlling who can access these services, how they are managed, how they are secured. That brings us to part 5, Identity Access Management and Azure Administration. Microsoft Entra ID. First we will explore Microsoft Entra ID, which is Azure's cloud-based identity and authentication system. Microsoft Entra ID helps you manage users and groups, control sign-ins authentication, enable single sign-on across applications, secure access to cloud resources. In simple terms, it is the identity backbone of Azure. ensures the right people have access to the right resources at the right time. RBAC, role based access control. Next, we will learn about role based access control. RBAC allows you to control who can do what in Azure. Instead of giving full access to everyone, RBAC follows the principle of least privilege, meaning users only get permissions they need, nothing more, nothing less. For example, developer may have access to app services. Database admin may manage SQL databases. A reader role may only view resources. This ensures strong security and reduces risk of accidental or unauthorized changes. Next, we will explore how to manage Azure resources. Azure provides multiple management tools: Azure Portal, Azure CLI, Azure PowerShell, Azure Cloud Shell. These tools allow you to manage Azure resources efficiently, whether manually or through automation. Next, we will read resource logs and governance. Finally, we will look at governance and protection features in Azure. Azure provides tools to protect your resources from accidental changes. Resource logs prevent users from accidentally deleting or modifying critical resources. Azure Resource Graphs helps you query and manage resources across subscriptions at scale. These tools help maintain control, consistency, and safety in large Azure environment. In part 4, we learned about compute, networking, storage, database. These are the core building blocks of Azure applications. In part 5, we learn how to secure those resources, control access to them, manage and govern them efficiently. So in coming session, we will mainly focuses on identity and access control and governance, ensuring Azure resources are secure, well managed, and properly controlled. If this lesson helped you understand Azure core services, don't forget to support the channel. Like this video if it made Azure concepts clearer for you. Comment below with your questions or share what clicked for you today. I would love to hear your learning experience. Subscribe so you never miss the next lesson on your journey toward the AZ-900 certification. We will continue building step by step, making Azure simple, practical, and exam ready. See you in the next session. Thank you.